Okay, I see my mistake here. What happened was I missed a negative right here, and it was right here. Here's the mistake. The cosine of pi over 4 is positive, and I put that as negative. So let me fix that. So that means when I distribute this to this, I'm going to get a positive. And when I distribute this to this, I'm going to get a positive. Okay, that's better. I get the square root of 3 over 2 minus 1/2 is negative 2 over 2, or a negative 1, plus 2 over the square root of 2. Negative 3/2 minus 1/2 is negative 4. I get a negative 2 minus 2 over the square root of 2. Wait a second. Let me make sure that's right, too. Negative, 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 negative 2. Yep. Okay, yeah, I'm okay with that. And so if I wanted to clean this up, you can always rationalize and simplify this complex fraction by multiplying by the square root of 2 over the square root of 2. If we do that, I'll get negative square root of 2 plus 2 all over negative 2 root 2 minus 2. All right, that is that one. Let's look at number 9. Number 9 says find the slope of the tangent line to cosine of 2 pi when theta is equal to pi over 4. All right, so let's do this. This is the same thing, basically. dy dx is dy d theta, which is equal to dr d theta. Let's figure out what dr d theta is, because we're going to be using it a lot. That's the derivative of cosine, which is negative sine, so it's negative sine of 2 theta times derivative of 2 theta, which is 2, so it's going to be negative 2 sine of 2 theta. That's what dr d theta is. So, dy d theta is equal to dr d theta, which is negative 2 sine of 2 theta times sine of theta plus r, which is the cosine of 2 theta times the cosine of theta, all over dx d theta, which is equal to dr d theta, negative 2 sine of 2 theta times the cosine of theta minus r cosine of 2 theta times the sine of theta. And they want this when theta is pi over 4. All right, so what we have here is negative 2. The sine of 2 times pi over 4 is the sine of pi over 2, which is a 1, times the sine of pi over 4, which is 1 over the square root of 2, plus the cosine of 2 times pi over 4 is cosine of pi over 2, which is 0. That's just going to be a 0. Down here we have negative 2 sine of pi over 2 times the cosine of pi over 4. So we have negative 2 sine of pi over 2 cosine of pi over 4 minus the cosine of pi over 2, which is going to be another 0. So what I get here is basically negative 2 over the square root of 2 over negative 2 over the square root of 2, which is 1. So that's the slope of the tangent line. So this last example, we want to find the points on the curve where the tangent line is vertical or horizontal. So let's have a look at this. Let's think about when is a tangent line vertical? Well, a tangent line is vertical when its slope is undefined. When is dy dx undefined? When the denominator is 0. So it is going to be vertical whenever dx d theta is 0. When is the tangent line horizontal? When the slope is 0. When is a fraction equal to 0? When the numerator is 0, or when dy d theta is 0. This is when it will be horizontal. So let's find dr d theta, because we will need this. Dr d theta is going to be 0 minus the cosine of theta. All right. So let's see. What is dy d theta. Well, it is equal to dr d theta, negative cosine of theta, okay, times the sine of theta, plus r, 1 minus the sine of theta, times the cosine of theta. So the question is, when will this be 0? Because what we're looking for is the horizontal tangent lines. All right. Well, let's do the math. Let's see. I have a common factor of cosine I can factor out. Let's factor out the cosine of theta, leaving me with a negative sine theta plus 1 minus sine theta, or the cosine of theta, 1 minus 2 sine of theta, is 0. When will this be 0? Whenever the cosine of theta is 0 or 1 minus 2 sine of theta is 0. All right, where is the cosine 0? Here and here. So when theta is pi over 2, or 3 pi over 2, or 5 pi over 2, or 7 pi over 2, there's many. And when will the sine of theta equal to 1/2 when I solve that? Where's the sine 1/2? Well, right here and right here. So at pi over 6 and at 5 pi over 6. This is where we think this curve will have a horizontal tangent. All right, where will it have a vertical tangent? Let's have a look at this. Well, when is dx d theta equal to 0? So let's find, this is the vertical. When, take dx d theta, let's figure out what that is. Well, that is equal to dr d theta, which we know is negative cosine of theta, times the cosine of theta, minus r, which is 1 minus the sine of theta, times the sine of theta. When will this equal to 0? So what we have here is negative cosine squared of theta minus 1 minus sine, oh wait, is this a plus sine squared of theta? Because that negative will distribute, is 0. All right, so what we need to do here is convert one of these guys. I'm going to convert sine squared to cosine using the Pythagorean identity. Sine squared plus cosine squared is 1. So I'm going to use that and say this is 1 minus the cosine squared. I just converted that guy. So what I get here, let's see, what do I get here? I get negative 2 cosine squared Did I lose a cosine somewhere? Hang on. Oh, I did this before. This sine will distribute. That's what I didn't do. Okay, that makes me want to change things. Sorry. I want to convert this differently then. Let me go back because I made a little mistake there. That changes which identity I want to use. So, all right, so let me distribute this properly. So I get negative cosine is negative cosine squared. Okay, then I have minus, okay, sine times 1 is sine. Then I have minus sine squared. All right, so now I have negative cosine squared theta minus sine theta plus sine squared theta. I need to convert them to the same trig function if possible, and it's possible. I'm going to use the Pythagorean identity, but this time I'm going to convert cosine squared into 1 minus sine squared, and the reason is because of this sign. I want to talk all sign language. So this is negative 1 minus sine squared theta is the identity I just used, minus sine theta plus sine squared theta is 0. So this is negative 1 plus sine squared theta minus sine theta plus sine squared theta is 0. This plus this is 2 sine squared theta minus sine theta minus 1 is 0. This will factor into 2 sine theta times sine theta minus 1 plus 1. Let me see. 2 sine times sine is 2 sine squared. Positive minus 2 gives me the negative. Negative. Yep, this is right. So this is going to be true when sine theta is negative 1/2 or when sine theta is 1. Where does this happen? Well, the sine of theta is 1 at pi over 2. All right. And sine is negative 1/2 right here and right here. So that's at 5 pi over 6 and 11 pi over 6. 11 pi over 6. So these are the values of theta where we get a vertical tangent. Now there is just one issue here, and that is that pi over 2 landed on both of our lists. And that's a little bit of a problem because it can't be both horizontal and vertical tangent at the same place. So what we will have to do here, and let me find just a blank piece of paper I can work on, is figure out what it is. So what we have going on here is that at that moment, we are saying that when you take dy dx, we get a 0 over 0 at pi over 2 because the dx d theta was equal to 0 and dy d theta was equal to 0 at this moment. So we can say let's use L'Hopital's rule. We can do that when we're trying to find, we want to find the limit as theta approaches pi over 2 of dy dx to see what's going on here. So what we got was this indeterminate form as is, 0 over 0. So by L'Hopital's rule, we can take the derivative, the limit as theta goes to pi over 2 of the derivative of dy d theta. All right, where is dy d theta? Here it is. This is dy d theta. So we want to take the derivative of this. So I'm going to use product rule. I'm going to say first times derivative of the second is 0. Derivative of sine is cosine, so it's minus 2 cosine theta plus second, 1 minus 2 sine of theta times derivative of the first. Derivative of cosine is negative sine. All right, and then all over the derivative of dx d theta, which is, where's the simplest form here? Maybe here. I guess this is where I'm going to do it. So this would be 4. If I use power rule, 4 sine of theta times derivative inside cosine theta plus minus cosine theta. All right. So as theta goes to pi over 2, what is happening here? Well, this would be a 0, 0. This would be 1 minus 2 times 1, 1 minus 2. Negative sine of pi over 2 is negative 1. So in the numerator, get 0 plus a negative 1 times a negative 1. We get a 1 in the numerator. Down here, the cosine of pi over 2 is 0 over 0. This guy's headed to infinity. What that tells me is that at theta is pi over 2, the slope's headed to infinity, so it's a vertical tangent. What that means is I keep it on my vertical list and I strike it off of my horizontal list. And that's what you have to do if you run into an indeterminate form. All right, that's the end of 10.3 polar coordinates and polar graphs.